Okay, let's go with part 2 of section 2.2 on conditional statement. One thing I forgot to mention is I forgot to write the word false. So you need to state the word false, but also come up with at least one counterexample. And I say at least, you really only need one counterexample, but if you come up with more, that's okay. It's not going to hurt anything. Like I came up with rectangle, parallelogram. You could also say rhombus. You could say trapezoid. Basically, any four-sided figure will make it prove that it doesn't have to be a square. Okay, now the next part is I'm not really going to spend a whole lot of time on it because I'm not going to test you over it, nor am I going to quiz you over it. But I do want to make you aware of it, and so I'm going to leave it in here. It says finding the inverse and the contrapositive. Okay, now all the inverse is if you negate the conditional statement. Now, when I say negate, you add one word, and that word is not. Actually, I'm going to use a different type of highlighter because use a different color highlighter because all we did was we negated the conditional. So instead of if a figure is a square, we said if a figure is not a square. Then it has four sides. Then it doesn't have four sides. That's all we did was we negated it. Negate means to go with the opposite. It's like taking a positive number and making it negative. That's all negation means. And you negate a statement by simply putting the word not. And then down here, the contrapositive is if you negate the converse. So if a figure does not have four sides, then it is not a square. You can also say by flipping the inverse, which is either one. I've put a couple examples up here for you. I'm not going to test you over that, but I do want to at least make you aware of it. So it's just a little bit extra information for you. All right. And then here's an example of a conditional statement with its converse, inverse, and contrapositive. So if an angle is a right angle, then it has a measure of 90 degrees. By the way, that is a true statement. If an angle has a measure of 90 degrees, then it is a right angle. That is a true statement. If an angle is not a right angle, then it doesn't have a measure of 90 degrees. That is a true statement. And finally, if an angle does not have a measure of 90 degrees, then it is not a right angle. That is a true statement. One thing I learned in one of my college classes, this was kind of interesting, that the contrapositive and the conditional always have the same truth value. Just because the way they're written, it's like saying not negative, which is the same as positive. So it goes on that format. A little bit of information for you, not really relevant to the class, but I thought I'd throw it your way. Okay, so those are all true statements. Now, that won't always be the case. Sometimes the conditional will be true and the converse will be false. Sometimes the opposite. Sometimes the converse will be true and the conditional will be false. It just depends on the statement. All right. Now, there's a couple more things I'm going to show you real quick, and then I'm going to we'll be done and let you get some time to work. Okay. A Venn diagram can be showed. So here's how to write a Venn diagram. You always start inside and then you go out. So since square is inside rectangle, that means that the square is part of the rectangular family or the rectangular group, which, by the way, is a true statement. We'll talk more about that when we talk shapes later on this year. All right, so the conditional statement says if a shape or a figure is a square, comma, then it's a rectangle. By the way, is that a true statement? It is a true statement. And notice I put the hypothesis in red and the conclusion in blue. Try to keep it consistent with what you've seen. So, and notice I also did not include the word if and then in either one of those statements. So you start in and you go out. I got one more for you. And then we'll be done. All right. If a number is whole, then it's an integer. It's basically saying the set of whole numbers is a part of the integers, and that the answer to that is true. Remember, whole numbers are 0, 1, 2, 3, 4, all the way up. The integers are all those numbers plus they're negative. So -1, 0, 1, -2, 2, -3, 3, so on and so forth. So this is also a true statement. You really won't be dealing much with Venn diagrams in here, but I at least want you to have some practice with it. So, okay. Now, you'll notice that the assignment is HW, as in homework 2-2. It's going to be a Google Doc, and I will have a video on how to execute that. And there'll be a couple other assignments in this chapter that we're going to be doing that with as well. So it's a little bit different format than what we've been doing with HQs on Canvas, because with the content of the material, it just works out that way, and this works better for you. So, okay, I will stop this right now, and you can get to work.